this is a chemistry review for my Bio 168 students who maybe haven't had chemistry in a while. And I'm just going to do just regular notes on notebook paper and go over the concepts that I saw in the homework assignment, okay? So I guess the first thing in any chemistry review that you need to understand are atoms and the subatomic particles that compose an atom. So I'm going to go over 3 examples of atoms with you. And atoms are the simplest forms of matter. They're found on the periodic table. They're not combined with any other substance. They're the purest, simplest forms of matter, and they're the smallest particles of matter that exist. So we're going to learn about the sodium atom and the chlorine atom, and we're going to learn about carbon, and we will probably also learn about oxygen and hydrogen, because those are elements or atoms that are found in a lot of what we're going to be learning in anatomy. So carbon, hydrogen, and oxygen. So atoms contain subatomic particles, and those are just protons, neutrons, and electrons. Every atom has, in the periodic table, every atom has an atomic number, and that atomic number tells you the number of protons, and the number of protons will equal the number of electrons. So the atomic number tells you the protons, which is equal to the electrons. Now, make sure you understand this. An atom has a neutral charge, so the protons are positive and the electrons are negatively charged. So in an atom with a neutral charge, you have the same amount of protons as you do electrons. But then when we start talking about ions, they're going to have different numbers of electrons than protons. But as long as it's called an atom and it has a neutral charge, then the electrons will equal the protons. But technically, the definition of atomic number is the number of protons. Okay? Now, you also will have an atomic mass or a mass number, and that will tell you the number of protons plus neutrons in the nucleus of the atom. Protons plus neutrons. So let's look at sodium. The symbol of sodium on the periodic table is Na. Its atomic number is 11. And its mass number is 23. It's actually 22 point something, but for our purposes, we just round that number to 23. So what this tells us is that since the atomic number Okay, so back to sodium, and the atomic number is 11. So that tells us that the number of protons is 11. And since this is a neutral atom and not an ion, the number of electrons will equal the number of protons. So there's 11 protons, that means there's 11 positive charges, because every proton has a positive charge. There's 11 electrons, which means there's 11 negative charges, because electrons are negatively charged. And this is what makes the atom neutral, is that the number of positive charges equal the number of negative charges. Now, the subatomic particle is the neutron, and you get that by subtracting the atomic number from the mass number. So 23 take away 11 is 12, and that tells us there are 12 neutrons. Now, the particles that are in the nucleus of the sodium atom are going to be the protons and the neutrons. So what we're going to do now is draw a sodium atom and represent in the nucleus, we're going to write our 11 protons as a P with a positive charge and our 12 neutrons as an N, with a neutral charge. You can either not put anything or you can put a little 0 for neutral. And then our 11 electrons have special locations. So our electrons are going to surround the nucleus and reside in energy levels outside the nucleus of the atom. So only 2 electrons can go in the first energy level. So that's the first energy level, and we can only have 2 electrons, and that energy level is filled. Now we still have 9 more electrons to go, because we have 11 total. So our second energy level will be filled with 8 electrons. In fact, all the energy levels after the first energy level are filled with 8 electrons. Okay? That's called the octet rule. So 1, 2, 3, 4, 5, 6, 7, 8. So that is 10 total electrons, and we have 1 more left because we have 11 electrons to balance out our protons. So that last electron is going to go in the third energy level. And since it is the very last electron and it's in the outermost energy level, we call that our valence electron. So the valence electrons are important because they're the only electrons that react with other atoms to form compounds and molecules. So what we can say is sodium has 1 valence electron. Electron. Okay, so the next one I said we were going to do chlorine. Chlorine, I'll go ahead and do the symbol on the periodic table. Let's see, chlorine has 17, I have to think. I don't have a periodic table in front of me. Chlorine has 17, that's its atomic number, and its mass number is 35. What that tells us is that chlorine has 17 protons and 17 electrons. And then 35 take away 17 is 18. And so it will have 18 neutrons. So here's the nucleus of our chlorine atom. It's going to have 17 protons and 18 neutrons. Just to double check, ask yourself if 17 and 18 add up to 35, and they do. So these two should add up to your mass number 35. Now we're going to have 17 electrons. The first 2 will go in the first energy level, and then 8 will go in the second energy level. 3, 4, 5, 6, 7, 8. That gives us 10. So we're going to have a third energy level, and we've got 7 left. So all those 7 will go in the third energy level because the third energy level is full when it has 8. So we can put all 7 in that third energy level. 1, 2, 3, 4, 5, 6, 7. So the number of